When you're working in 3D, there are a number of conventions that need to be followed, and also there are tools and tricks that can help you to work within those conventions. Up to this point, I've just been working away in 3D space without really dwelling on what I'm doing. In this chapter, we're going to look at those conventions and how they help us to work and model within the virtual 3D space in 3ds Max. After all, for new users, it may not be very intuitive. So let's make a start with the topic of coordinate systems. Let me give a quick explanation of transforms before we go on here. In all 3D software, we're constantly going to work with what are known as transform spaces. These are simply graph-like grids with three-dimensional coordinates. If you remember 2D graphs from your math classes, you'll know that you can specify any position on that 2D graph by using two axes. And the two axes are usually known as x, and x defines the value along the horizontal axis, and y, and that defines the value on the vertical axis. And by supplying any of those two coordinates with a certain value, you can specify any position along the positive x-axis, negative axis, the positive y-axis, or the negative y-axis. And by using a combination of those coordinates, you can basically define a position anywhere within 2D space. So simply by supplying two coordinates, you can define any point in 2D space. But of course, that would be a little short of the mark when you're working with a 3D piece of software like 3ds Max. So for 3 dimensions, we need another axis in the graph that runs, as it were, towards us and away from us. In math, this axis is generally known as the z-axis. And when you're doing equations, you'll find that you will be using values of x, y, and z when you're working with any kind of 3D values. Those values of x, y, and z go for pretty much all 3D software, and x is usually, as I said, the horizontal axis, y is usually the vertical axis, and z is usually the depth axis. But in 3ds Max, it's actually a little bit different. So let's have a quick look at that now. Here's a pretty simple 3D graph that I've actually created here in 3ds Max. And this may give you a better idea of what I mean about the three coordinate systems in a 3D piece of software. And it also illustrates the difference in the axis labeling that I just alluded to. Now you can see here we have the x-axis, which is our horizontal axis. In 3ds Max, the vertical axis is actually called the z-axis rather than the y-axis. At the end of the day, don't forget, it's just a label. It doesn't really make much difference to maths at the end of the day. And then the depth axis is called the y-axis, which you can see here. Now, these axes combine together to create a full three-dimensional space, which is why we can see this three-dimensional object here. It's actually described by using these three axes. But you can also think of them in pairs of two, and each pair of two axes creates a plane. So if I was to look directly down this axis here, what we're actually looking at are two of the axes, the z-axis and the x-axis, and this defines a 2D space. And you can see I've actually combined the two colors of the two axes here, blue and red, and I've created this magenta plane here, and that actually represents the plane that these two axes actually combine to define. If I look along the x-axis, we're now looking directly down there, and what we're looking at now is the z-axis here, vertical, and you can see the horizontal axis here is the y-axis. In this case, it's depth. And again, I combined the two colors, and you can see it defines a plane, and that's the, as it were, the ZY plane, or the YZ, whichever way around you want to organize it. And that defines this plane here. So there we are, we can see it. There's the plane in 3 dimensions. And again, if we look down from above, we're now looking down the z-axis, and you can see we're now looking at the x-axis here and the y-axis here. So we're looking at the x-y axis. And so you can see that in 3ds Max, as it were, the x and the y-axis defined, as it were, the ground plane. And again, you know, I've done a color combination, red and green, making yellow. So you can see there is the xy axis, or what can be thought of as a ground plane. Now, in 3ds Max, this graph that you can see here, this three-dimensional graph, is used to specify the positions of all of the objects in the scene. And because of this, it's known as the world transform. It's effectively the transform space that defines the world that everything lives in inside a 3D scene. So it's very fundamental to any 3D scene. You know, it's the basis upon which everything is built. The world transform is used to define the object's position. The world cannot be moved, it cannot be rotated, and it cannot be scaled. And this may sound self-evident, but it's not necessarily so. Other transform spaces can be scaled, and they can be rotated, and they can be moved. But don't forget here that this is the basis of an entire scene. So it actually makes sense that it's immutable, cannot be moved, cannot be scaled, cannot be rotated. But basically all other rotations, scales, and movements are based on offsets from the world. It's pretty basic to pretty much all other transforms in a scene. So it kind of makes sense that it can't be changed. As I said, it's the basis of everything. When we create 3D object in the view, for instance, if I create a quick teapot here, and I should point out this has to be a perspective view for this actually to be always the case. Its orientation, the orientation of the teapot, and the scale of the teapot is inherited from the world transform. Its position is defined using the world transform coordinates. It's an offset from it. So if we look at this object, you can see that it has a y coordinate here of -24. You can see it has an x axis coordinate of 26. So if I adjust this value by grabbing the spinner and moving it, as I move it towards 0, you can see it's moving it towards the 0 point of the world here on the x-axis. And I can actually right-click the spinner, and that will 0 it, banging it straight onto the center of the x-axis, right on the 0 point here. And I can do the same thing for the y-axis. I can, either use the spinner to increase or decrease the value. And if I 0 it by right-clicking on the spinner, that very quickly snaps it to the 0 value on y. And you can see the teapot is now moved to the center of the world. Now, if I create a few more objects, I'll just create a cube, and I'll create a pyramid. Create a pyramid there, and we'll create a torus. There we go. And you can see that in each case, the objects start off being positioned wherever I place them, but they all have a rotation of 0 on all three axes, and they also all have a scale of 100%. So let me just show you that. If I click on this object here, you can see when I actually change transforms, these values down here change relative to the transform that I'm currently working in. So when it's movement, they're the translation values. When it's rotation, they're the translation values for rotation. When it's on scale, you can see the scale values here. So if I go to rotation, you can see the rotation values are 0, 0, 0. Click on the cube, 0, 0, 0. Pyramid, the same. Teapot, the same. So you can see that when you create objects in Max, when you click in a viewport and you drag and create a primitive, the rotation is always the same as the world, i.e. 0, 0, 0. If we look at the scale, click on here, 100%, 100%, 100%, and 100%. Again, it's inherited from the world. There's no difference between the scale of the world and the scale of these objects. It's exactly the same. The only thing which does vary is the actual position, the position transform. So you can see it's changed here, and changed here. Of course, I can take any one of these objects and I can move them further. Get this teapot and move it again. I can rotate it. Let me just move it freely around. I can do the same here. This object and also this object. There you are. They've all just been rotated around some. I can scale them. Just going to scale this a little bit. Scale this object here a little bit. Same here. And I'm going to just scale that down here. And when I've done that, the values for rotation and scale for each object, they're all relative to the world coordinate system. So basically, they're all offsets based on the world coordinate system. you can actually think of all of the objects in the scene as being, as it were, children of the world coordinate system. And if an object is the child of another object, for instance, I can actually give this torus a parent, this cube. Now this torus is the child of this cube, and the cube is a child of the world. So you get these kind of relationships going on here, and some people don't realize it, that you can get this torus and you can make it a child of this cube, but all of the objects in the scene there, as it were, the ultimate parent of all the objects in the scene is the world coordinate system, and all transforms at the end of the day are derived from the world coordinate system in one way or another. So before I go on any further, just to make it a little bit clearer here, it can get a little bit boring sometime referring to position, rotation, and scale in long form all the time. So in some cases, I might refer to position by the phrase pos, rotation as rot, and scale as scale. Can't really abbreviate scale any shorter, can you really? And if I'm going to refer to all three of these transforms in one go, I'm going to use the abbreviation PRS. And this is a common abbreviation that you'll see in the rest of 3ds Max. So when we're talking position, rotation, and scale, I might say PRS, pos, rot, or scale. If we wanted any of these objects to use their default coordinates on position, rotation, scale, PRS, and to effectively center them to the center of the world, we can enter 0, 0, 0 on their position. We can enter 0, 0, 0 on their rotation. That will reset it back to 0 rotation on all three axes relative to the world. And we can set the scale back to 100, 100, 100. So let's try that now. First of all, position. That's very easy. I'll just do it for one of these objects for now. We can just right click that there to 0 the position on the x-axis. Do the same for the y-axis. Go to rotation. You can see you've got a number of rotations here, 52 degrees. And just rotate that. Oops, hang on a second. I just realized something. This torus is actually the child still of this cube, and therefore some of the transforms that I'm doing are in relation to this cube, which can cause problems, which is something that we'll come to later in this DVD. So let me just undo some of those transforms there. And what I'm going to do is I'm going to break the parenting. And let me just check that's the case. Yeah, I can now move that. So let's start again. There's the transform. I'll just move it there and there. Then we'll go to rotation. And I can do rotation just by pressing E on the keyboard. And there are the translations for rotation. So 0 that, 0 that, and 0 that. And now we can go to scale, and you can see we've got some scaling issues here. So, and I can go in and fix that just by right clicking on here. And I can put in 100%, 100%, and 100%. Now, if you look at this object, you can see that it's in the center of the world, and its rotations should be pretty much zeroed. Actually, they're not quite. Just zero those there. You can see the rotations are 0 to the center of the world. It's aligned with the world, it's in the center of the world, and it has a scale of 100% on all three axes. So it's actually back to what it used to be previously. We can do the same thing for the teapot here. I'll just reset the scales, 100%. Then I'll reset the rotational values. And then if I wanted to, let me just move this out of the way. Otherwise it's going to get a little bit cluttered there. And then I can center it to the center of the world just by clicking on those values. We can do the same thing here. I'll just do this very quickly, 100% and 100%. Change the rotation values very quickly, 0 those. And then I'm pressing W to actually change to translation. 0, 0, 0, back to the center of the world. I think you've got the idea how you can actually get an object back to its default position, scale, rotation, and so on. And also, if you want to snap it to the center of the world, you can just set these values to 0, 0, 0, as long, of course, as that object is still a child of the world. Earlier, this torus became a child of the cube, which meant that zeroing things here, it wasn't necessarily going to get it back to the center of the world. So it's important that, obviously, before you try doing this technique, you make sure that the object is a child of the world rather than anything else. When we create an object in a perspective viewport, as we've been doing here, usually, again, as we've been doing here by starting with a primitive, its pivot point is aligned with a world transform. This is something that I've been showing you. Also, implicitly, its geometry is also aligned with the world. What I mean by that is, if you look at these objects, you can see that this teapot is aligned along this axis here. You can see that this torus is aligned with the axis of the world. You can see here the cube at the moment is actually rotated, so ignore that, but it was created in alignment with the world. And you can see the same thing for the pyramid. They're all the geometry of each object is actually aligned with the axis of the world, with the world transforms. And this is such a natural and obvious thing that we don't really question it generally. This alignment, though, means that when we move an object along its x-axis, we're also moving it along the world x-axis. And the same goes for the other two axes as well. You know, if we're moving on y, by default, when we've just created the object, we'll be moving it along the y-axis, then we'll be moving it along the world y-axis, and the same for the z. However, when we rotate the object along one of its own axes, or more than one of its own axes, we're moving away from the alignment of that object's pivot point to the world transform. And when we do that, this is where the concept of local space comes into play. When we rotate an object, its own axis goes out of alignment with the world. This is pretty obvious. If I get this teapot and I rotate it, now its axes are out of alignment with the world. Actually, to be able to see that, I need to go to local here. And you can see now that the axis of these rotation gizmos here, we just changed that to local as well. And you can see these axes, they've all gone out of alignment with the world, and they've taken on their own life. You know, as I rotate the object, you can see its own axes take on a different alignment. So it's got its own local axes along which the object can be transformed. And that is in terms of position, rotation, and scale. This reference system can be at any kind of angle compared to the world. When we move the object along one of its own axes, it could be very easily moving along two or even all three of the world axes at the same time. And the same goes for rotation and scale. If we rotate an object based on its own axes, we are probably moving relative to the world in all three rotation axes at the same time, even if locally we're only moving along one axis. Let me just show you what I mean by that. If I turn on rotation and if I just rotate along this axis, locally we're only actually rotating here along the, let's see, the x-axis, but I don't know if you can see that, but that axis runs at an angle to all of the world axes. So we're actually probably rotating the teapot in all three world axes at the same time. So that's important to remember. You might be moving in one axis locally, but in terms of the world, you're very probably moving in multiple axes at the same time in relation to the world. So as I said, once rotation comes into play, we have to think about what coordinate system or what transform space we want to transform our object with. Do we want to use its own local coordinate system? Or do we want to use the world coordinate system? And indeed, if we want to, we can actually pick any arbitrary coordinate system in the scene. At the moment, I've only rotated this object based on world space and its own local space, but it's actually possible if you wanted to rotate this torus over here, pick the transform space of this torus, and then carry out any other transforms on this object in the transform space of this torus. You may have just noticed that I used a certain part of the user interface to define what coordinate system I wanted to transform this teapot in. This is up here. It's a little flyout that you can see up here. Very, very important. And as you can see by the tooltip, it's called the reference coordinate system. I'm not going to show you all of the options in the reference coordinate system, only the ones that you really need to use at this point I'm going to go over. Anyway, here's a quick run through of the main options, and as ever, if you want a fuller explanation, more in depth, please use the online help. Here it is, user reference. Fantastic resource. If you type in, whatever it is that you're interested in, you'll usually find that it gives you a very quick outline of what that feature is all about. And if you wanted to type in the reference coordinate system, it would give you a very in-depth run through of all the different options. So I'm not going to do that here. I'm just going to run through the main options. So let's do that now. So the first option we're going to look at is view. And what this does is it gives you a fixed coordinate system that is based on whatever view you are currently in. Personally, in some ways, you can find this, I think you can find this a little bit confusing because it's not a fixed coordinate system. It's a relative one. It's based on whatever view you're taking on the scene at that moment. What it does is, whatever view you're in, Y is aligned along the vertical axis of the screen, X is aligned along the horizontal axis, and Z points along your view into the screen. This works pretty well as it gives you a consistent reference space within which you can move your objects. However, in the perspective view, X and Y are aligned along the home grid, whilst Z is along the vertical axis. So let me just quickly show you what I mean by that. So if I get this object and change that to view, there we go. So you can see now that, let me just change to wireframe. You can see that Z is aligned along the vertical axis, X is aligned along the ground plane as it were, and Y along the ground plane. So you've got these two axes here. If I change to a front view and we look at this teapot, you can see now that it's changed. And if I just move this up here so you can see it a little bit more clearly, you can see that Y is now vertical. As I said earlier, Y is aligned vertically, X is left to right. So if we move this around here, you can see we're moving in the XY axis, and we're in the front viewport here. If I change it to the left viewport and select this object, you can still see that we're still looking along X and Y. So these coordinates are not using the world coordinate system. These coordinate systems are relative to the camera. So don't get caught up in any kind of illusion here that you're working with a world coordinate system. You're working with a coordinate system which is based on the view that you're looking through. If I look through from the top, you can still see, yes, yet again, we're looking at Y up and X left, right. So you can see that in any of these sort of orthogonal views, top, left, right, you can see that X and Y always define X is left to right, Y is up and down. But when we go to the perspective view, that changes. Up and down is actually Z, and Y is the sort of horizontal plane. The next option is screen. Let me just choose that. Similar to view, but in some ways maybe a little bit more logical. What it does is it aligns the coordinate system to the screen space. The align, basically it's using, as it were, the coordinate space of the camera that you're looking through to define the axes of your object. You can see Z is pointing in and out of the camera, X is left to right, Y is up and down. And you can see that as I orbit around the object, that always stays relative to the camera that we're looking through. If we look through the left view, you can see X and Y is the same. If we go to the front view, X and Y is the same. Top view, the same. Perspective, the same. So I actually think this is a little bit more consistent. Obviously, you haven't got the ability to move the object up and down. So if you need that, obviously, if I'm going to move it here, it's not going to be relative to the world. You know, that's the one advantage of using the view option, is that any kind of adjustments that you make to the object are going to be aligned to the world transform space. You can see X and Y are aligned to the world. But if we change to screen, it's not really aligned to anything apart from your camera. The next option down is the world. This is world transform space. So it should be familiar to you by now. So we have the X-axis here, Y-axis here, and we've got the Z-axis here. This is immutable. If we change to the top view, we're always going to be looking along the correct axes. Y and X is visible from the top viewport. If we look in the left, we can see Z and Y, and this corresponds with the diagram that I built for you here. And if we look in the front view, again, you should find there's a correspondence. You've got the X-axis here, Z-axis vertical. You can see this matches up with this here. So whatever viewport we're looking in, we're working with the world coordinate system. So obviously, it's useful for where you want to move objects relative to the same space to each other. You know, if you want to move an object left to right and you want to know that this object is going to move along the same axes and planes, then you want to use world coordinate system or view. You want that to, you know, as we saw earlier, it's akin to world, but not quite the same. Varies depending what viewport you look through. So personally, I prefer to use world a lot of the time because really, you know what you're doing when you're working with world. You know that when you're moving an object along the y-axis, it really is the y-axis. The z-axis really is the z-axis, and so on and so forth. For the next option, I'm just going to create another object here. I'm going to create a teapot. I'm going to move it over here. And I'm going to link it to this pyramid here. That's going to make it a child of the pyramid. Then I'm going to rotate the pyramid a little bit. Also rotating the child. There we are. So, and if I move this teapot in world space, you can see the coordinates are based on the world, which is perfectly sensible. But if we go to the next option, which is why I've actually set this up like this, which is parent, you can see that the axis of the object are now aligned with its parent. Now, in this case, the axis of the parent and the teapot's own local axis are exactly the same. So let me just show you that I'm not doing some kind of voodoo here. I'm just going to rotate the teapot around a bit. Let's put it upside down and move it up here. And you can see that when I'm moving it, it's in parent space. And that parent space is aligned to the pyramid here. If I rotate the pyramid slightly, let's just put it down here like this, go back over here and click on the object, you can see that again, it's in the transform space of its parent object, which in this case is this pyramid here. Let me just rotate it around a little bit more. Let me just make it obvious. Just rotate it a bit more. Extreme angle again. So there you go. You can see that this grid here, this axis is aligned with the parent object, this pyramid here. If I go over here, you've got a different axis. Here, I've rotated this torus. And if I take this teapot and I make the torus into its parent, now you'll see that the coordinate system is aligned to this object over here. So we can actually move this around. Let me just move this here. Move it there. I can zero it. And you can see that when I zero it, it's zeroing it to the center of this torus here. And you can see, there we go. I've actually zeroed it to the view. So what I'm going to do is I'm going to choose parent space. And I'm going to zero it to parent space. And you can see now that I've actually aligned this teapot and I've actually moved it to the position of this torus by zeroing its values. But to do that, I had to do it in parent space. Now, if I wanted to do the same, if I wanted to move it over here, I could then link it again back over here to this pyramid, and then making sure that I'm using parent space for translation, W, and rotation. Yep, we've got parent as the reference coordinate system for both. I can now zero the values again, and I can do the same thing. You can see a slightly out of alignment. But if I go to rotation and I do the same thing, it's on parent, zero the values. And you can see now that the teapot is aligned perfectly with the pyramid. So you can see by using parent space, you can actually align an object with another object very easily and There is one last thing actually I should point out here. If the object is not a child of anything, if I break this connection to this object here by clicking on that icon, just move it over here. Now, when I center it, and I do the same thing for rotation, you can see it's aligned and it's moved to the center of the world. And that's because if it's not the child of any object in the scene, then it's a child of the scene. It's a child of the world. And therefore, when you choose parent and an object doesn't have any parents, you may as well choose world because you're going to get exactly the same result. And the next option is very important, local. That is actually the local coordinate system of the object itself. And we'll make sure that we'll do the same thing for translations as well. We'll choose local. And now, when I move the object and when I rotate it, you'll see that the gizmo here for translations is always aligned with the object itself. That's because the transform space is local. So you're always looking at moving the object within its own transform space. One of the upshots of using local is that any translations that you do down here are relative to the object's own translation space. And because the translation space of the object is always in the center of the object, you can't zero the values down the bottom here because they're always zeroed. You know, if I'm going to zero the translations, the object's not going to go anywhere because it's already at zero. Basically, the local transform is already at the local transform, so you can't really zero that. We look at rotations. Again, they're zeroed because, of course, the rotations are relative to its own local transform. It's always going to be aligned to its own local transform, so there's no way you can zero that either. So that doesn't really make any sense whatsoever when you're working with local space. You can't zero out values to align it to local space because it already is. And of course, the advantage of local space is that you can scale an object along its own logical axis. We'll need to change scale here to use local as well. Now you can see I can actually scale the teapot along its own height, its own x-axis, its own y-axis, or any combination of those. I'll just do it on, what's that, x and y at the same time. I'll just undo that with Control Z. And you can do the same thing with any of the axes. I'm just going to rotate it on its own x-axis. You can see as I rotate the object around, the rotation gizmo rotates with it. So there you go. You can see you can manipulate the object in its own local space, and this is very important when you're doing a lot of modeling. You'll want to manipulate things in local space. Local space and world space are the two most useful coordinate systems, reference coordinate systems while you're modeling. The others are useful. Parent is also very useful in certain circumstances, but you'll find the two, as it were, core reference systems are world. After all, world defines everything, and local space. And obviously every object has its own local space. Very often when you want to move an object within its own geometric alignment, and that will generally be based on local space. So local space is very important. And the last option we're going to look at is pick. Now pick is very, very similar to parent, except that the object doesn't actually have to be a child of the object that is picked as the reference coordinate system. So let me just show you that. I'm going to pick this torus here as a coordinate system. So you do that by going down to pick. Then you have to choose it. And now I've chosen the torus as the reference coordinate system. If I go to translation, you can see it's gone to local. But if I go down in the list now, you can see at the bottom, we've got a picked coordinate system. So we've defined a new coordinate system that we can use. I'll click on torus. And you can see now that the coordinate system here is aligned to the torus. And let's do the same thing for scale. So you can see that each reference coordinate system is now using torus as the option. So I'm going to zero out these values. So there we go. We've snapped over to the torus. And I'm going to go to rotation, do the same thing with rotation as before. And again, you can see the teapot is aligned to the torus. Obviously, it's not a child of the torus, so I can actually move the torus around and the teapot's going to be left in place. And you can do that as many times as you want, really. You can go up here, pick, choose another coordinate system. Let's choose this pyramid over here, pick that, let's pick it for translation, rotation, pyramid, and pyramid. There we are. And again, zero out the values. Oops. I'm doing it for the torus. Zero out the values. And it's snapped over there. Do the same thing for rotation. There we go. And I can do the same thing with the torus now. I can actually snap that in there. It's into the same alignment. And we can move it over there. Fully zeroing it. And they're all using the pyramid's own transform space. We can move things around. So I move that there. And I move that up there. You can see they're all aligned to the coordinate space of the pyramid. So that's it for reference coordinate system. I think you should have a pretty good idea of what transform spaces are now and how they all combine together to allow you to transform your objects. You've got these different coordinate spaces and each one is useful. Depending on the circumstance, you're going to be using world space, local space, parent space, pick space, whatever. Whatever space makes the most sense for you at the time, you can choose the reference coordinate system up here and transform the object in the space that works for you at that particular moment in time.